Method of adding and subtracting vectors. Head to tail method. This involves drawing vectors to scale on a sheet of paper, beginning at designating starting position. Okay, where the head of the first ends, the tail of the second vector starts. So basically, in simple words, what you've got here in this picture, you've got three vectors. Okay, three vectors, and you have to add them up. Remember, when you add vectors, do not change the direction of the vector. Never ever change the direction of the vector. The direction of the vector stays as it is. So here you can pick any vector first. It's your call. Okay, there's no specific procedure of adding vectors. You want to add the right vectors first, or the left one first, or you want to start from the top or bottom. No, you pick any one and you keep on adding. The result will be the same. So what we've got here, if you pick this vector first, as shown in the diagram, I've got this vector here. So the on the head of the first, you draw the tail of the second. And that's how you've got the second vector here. And you keep on doing that. If you've got 50 vectors, you keep on doing that. You add it up. All vectors. Remember, the first vector, the head, you connect the tail of the second. Okay? And you keep on doing this. Okay? Doesn't matter if the vectors are going in a circular direction or are going in very awkward directions. You just keep on doing this. And in the end, you connect the tail of the first with the head of the last. And that is basically resultant vector. Okay? I'm sitting here on the table. My force vector is down. Okay? I'm holding a bottle. It's got a weight. Okay? It has also got a force being applied down. So you got two forces now. Okay, so if you want to resultant, it's basically the force plus this force. That would be the resultant. That would be the resultant force being applied on the table. That's the resultant. Okay, I've got a glass also. I've got three forces. What's the resultant? There'll be one force acting on the table. If you are doing analysis on the table, you want to know that one force. You are not interested in how many items Riaz Mufti is holding. You need to know one force that is acting on the table, and that is resultant force. So you need the result of three forces. Okay, is that clear? So you need the resultant force. Okay, parallelogram method. That's also similar kind of thing, but you've done this also. In this method, what you do is you add two vectors, you get the resultant, and then you add a third vector to resultant, and then you get another resultant, and then you keep on adding one vector to your resultant, like it shows here. I've got in the next slide also. I've got two vectors A and B. In parallelogram method means you need to draw a parallelogram, which means I've got two vectors here. Okay, that's A and B. I will join them from the tail. That's here. It's been joined. I will draw parallel lines for both the vectors. This line is parallel to B, and this line is parallel to A. I will draw the parallel lines, and then I'll draw a diagonal. That's it. So if I've got a third one, if I have a third vector, what I'm going to do, I will, let's see, I've got a third vector, which is C. Okay. So I've got the resultant of AB. I will rub off A and B. I'll be left with this resultant. To this one, I will add a C. And then I will draw a parallelogram, and then I will get a resultant. To that resultant, I will add another vector and keep on doing that. It's relatively lengthy. The shortest way is using head to tail method. You combine all the vectors and you get your resultant out. And the third one is basically in parallel method. If you got a triangle, because this gives you a triangle, this one gives you a triangle. Look, if I've got this vector here and I apply another vector, okay, if I apply head to tail rule to A and B, if I use head to tail rule to A and B, I will have my B here and A here. Okay. If my A is here, then head to tail rule gives me that this is my resultant here. Is that clear? If I apply head to tail rule on this example, I draw my A vector and then I draw my B vector. And this is my resultant. I draw B and then A, or I draw A and then B. You can see the resultant is always the same. So as I said, if you've got force being applied on any object, doesn't matter where to start from. The result will be the same. Okay. So once I've got a triangle, you've got the sine and cosine laws. You can solve the problem. You got the angle, you got the magnitude, you can get this out. I'm not going to teach you maths. This is just simple, okay? What happened? Okay. And algebra is something that trigonometry basically is that you got a triangle and then you got your values out, and algebra is another method I'll show you in the coming lectures. Yeah, this is where I've got it shows you how to it demonstrates the parallelogram method, which says that I've got two vectors 6 and 3. I get the resultant out of this one. I then get rid of the two vectors, and to this one I develop another parallelogram and get the resultant out, and that's my answer. So in parallelogram method, remember, two vectors, you get resultant, you add another vector to resultant and get the next one, and you keep on doing that. In head to tail, it's easy. Just add on vectors and you get the result out.